Good morning, good afternoon, good evening, wherever you're hailing from. Welcome to another edition of the Ask an OpenShift Admin show here on OpenShift TV. I am Chris Short, executive producer of OpenShift TV. I am here with the one and only Andrew Sullivan. We're going to talk about what today, Andrew? We got a special guest and everything.
We do. ETCD or etcd as it's sometimes called. And first, I want to say I'm super excited about that intro animation. I'm really happy with the way that came out, and can't say enough nice things and great things about the team that put that together for us. So if they happen to be watching, thank you
this morning. Yeah, but seriously, it's awesome. Thank you very much.
Yeah, so thank you, Chris. This is the this is the Ask an OpenShift Admin Office Hours live stream. So the goal of this is to give you, our audience, the opportunity to ask us quite literally anything that's on the top of your mind. We're here to kind of help you work through all of those issues, any outstanding questions that you might have, and help, right? Whether or not that is we might have an answer or going back and finding the answer for you. So please, at any point in time, feel free to post into chat across all of the various platforms that we're streaming across to ask us any questions. However, in the absence of those questions, hello, Walid. In the absence of those questions, we do have a topic. And today's topic is one that I have been super excited about since the day I put it onto the agenda. It's something that pushes all of those good happy buttons for me, because it's kind of in the weeds and it's kind of super geeky and how it works. And there's a lot of different stuff that goes into it. So with that in mind, I am very happy to introduce our guest, Anand. And Anand, please introduce yourself. I'm not going to butcher your last name. I'm sorry.
No problem, Andrew. Thanks for the wonderful introduction. My name is Anand Chandramohan, and glad to be again on this OpenShift TV. Chris is an awesome host. I think a couple of months back we did a few sessions on Windows. Now glad to be working with Andrew and Chris again for HCD. Just as a background, I'm the product manager for HCD, so I'm responsible for the roadmap planning and future direction of the product. So any questions you may have about the futures of the roadmap, here to answer those away, or find out answers that we can come back with.
Yeah, and as you pointed out, you were here to talk about the Windows container side of things, and like basically all of us, you have multiple roles, multiple responsibilities. So for anybody who caught those episodes before, don't be alarmed or don't be surprised. Anand hasn't abandoned any of those. Do we ever get to abandon things? I don't think so. We only get more.
We deprecate them. Yeah.
Yeah. So it's just another hat that he happens to wear.
Right.
So in unusual, somewhat unusual fashion, usually I have an agenda for these where it's a loose agenda, right? Everybody knows I like my sticky notes. This one we have an actual Word document or an actual Google Doc, and it's like 2.5 pages. So
yeah, it's like it's ready for a book to be written.
It honestly is. So I really want to devote as much time as possible to today's topic, because I think it's a big topic. It's a complex topic. There's a lot of questions about it. It's a little bit of a black box, right? ETCD is to a lot of folks. But I do want to quickly cover, in traditional Ask an OpenShift Admin Hour tradition. I used traditional twice there, didn't I? Just a couple of things that are top of mind, things that I think you all should be aware of that have come up either internally or externally. So the first one, very short, very sweet, very simple. OpenShift 4.6.21 is on the cusp of being the first 4.6 stable upgrade to 4.7. So
cool.
It is in the, and I'm going to go ahead and share my screen here. Click share there. We'll move your lovely pictures over here, so it looks like when I look at you, I'm looking at the camera. If we go to github.com, I don't think I'm typing that right, but I can't see because your pictures are there.
Move our pictures.
And if we go to the Cincinnati graph data repo, so you see I'm just in github.com/OpenShift/Cincinnati graph data. So this, remember, is the repo that it pulls all of that information in for updates, upgrades, etc. You can see that there's an open PR to enable 4.6.21 in the stable channels. So usually takes a couple of days after these are submitted. So like I said, it's on the cusp of being available. That doesn't mean that it will. That doesn't mean that they still won't. You know, there might be some late breaking thing that will cause it to delay. But for anybody who's on 4.6 and ready to go to 4.7 in the stable channel, we're almost there. You know, I think all three of us were here back in the 4.4 days, right? The upgrade from 4.3 to 4.4 in stable took a long time. And the engineering team, the product management teams have done a lot of work to make sure that doesn't happen again, that we can make those updates happen a lot faster.
Yeah. And it just gets better and better with each release, I feel like, too.
Agreed. So the second thing that I wanted to bring up real quick, this one has caused a little bit of reoccurring drama. So if I go to the docs here, and I want the 4.7 docs, and I go to installing, and I want to install to vSphere. If I look at the requirements here for installing to vSphere, it's interpreted, it's not a stretch to interpret that we're saying the minimum supported vSphere version, right, using NSXT, right? It's easy to misinterpret that and say, oh, well, in order to deploy OpenShift to VMware, I need NSXT. So we've got a couple of BZs open with the docs team to basically clarify it's not required to use NSXT if you want to deploy to OpenShift or OpenShift to vSphere. But if you do choose to use NSXT, then there are some version requirements associated with that. So just a quick one. This comes up every week or two. I get an email asking, you know, oh, is NSXT really required? Well, no. So just be aware of that. And last but not least, I had a question come into my inbox about the default storage classes created with IPI and UPI. So if you deploy to, for example, vSphere using IPI or UPI, the installer will automatically configure a storage provisioner, the N-tree vSphere storage provisioner in that case, and will automatically configure a storage class. It's named thin, it is configured as the default class, and it's pointed to whichever storage domain or data store the VMs sit in. So you cannot delete that storage class. If you do, it will get recreated. And that is done by the cluster storage operators. I'll go back to GitHub. And if we search for storage here, as soon as I spell storage right, still can't spell storage right. Here we go, cluster storage operator. So this cluster storage operator is responsible for making sure that there is always at least the one defined storage class for each platform in the cluster. So you can, for example, change that storage class. If I want to keep the thin storage class, I want to keep it as the default, I can go in and modify it to point to a different data store, for example. I can create a new storage class and mark it as default. But that thin storage class, in the case of vSphere, and it's different for each one of the platforms, but that thin one has to be there. And if I delete it, the operator will recreate it and remark it as default. So just be careful if you're doing that. Make sure that you're aware of that behavior. If it seems weird, like, oh, I can't delete it, or, oh, every time I try and set a new default, it goes back. Well, make sure you're not setting a new default and then deleting the original, which will cause it to recreate.
Yes.
Okay.
Cool.
So I'm going to ask you a question, Anand, and then I'm going to catch up on chat while you answer, and I'll also be listening to you, of course. So the first question I wanted to ask, right? So coming back to our topic of the day, right? etcd. So what is etcd? What purpose does it serve? Kind of how does it function inside of, not just OpenShift or Kubernetes, but in general?
Yeah, etcd, I'll keep it simple, right? So etcd is basically a key value store for, storing the state of your, cluster. So your config maps, your secrets, and, other, protected resources are stored in the etcd. And, like the title of this, session says, it's really the heart of, the control plane. So that's essentially what it is. And, it's an open source project, and it's, very much a critical part of the control plane. And, we have built a etcd, operator that watches for changes to the cluster and, reacts in a certain way. And, over the course of this session, we'll talk about how you can, back up the store, how you can restore the store, how you can encrypt, decrypt the store. but it's really, at the core, it's a key value store for storing the state of your, your control plane.
And I think that's important because it's kind of a database, but kind of not a database, right? You specifically use the term key value store. And how is that different from a database?
Yeah, it's different from a database in the sense that this is not, your traditional Oracle RDBMS where you store inventory data or, customer, fleet management data. This is, meant purely for storing the internal state of the cluster. And this is not meant for any user level workloads, like for storing, like I said, inventory information of your shipping application, right? That's how it differs from a traditional database.
And etcd, it was originally created by the CoreOS team before they were a part of Red Hat.
That is right.
Okay. So etcd, key value store, it is used for the persistence layer inside of Kubernetes, or not all Kubernetes is, but many Kubernetes is, and most relevant for us today, OpenShift. So what types of things does OpenShift and Kubernetes store inside of there?
Yeah, you could use it to, like I said, store config maps, secrets, routes, OAuth access tokens, OAuth authorization tokens. Those are a bunch of things, you can store inside etcd.
Okay. Yeah, usually the way I think about it is anything that's YAML is inside of etcd, right? Of anytime I create some sort of object, it is being stored inside of there. And it's important because, okay, I create a new pod, right? I submit it to the API as that YAML definition. The API server then modifies etcd, right? etcd, it adds in that object. And then the scheduler does some work, right? The scheduler says, hey, there's a new pod definition. I need to schedule it. And it will update that object with the chosen node, for example, and notify that node that it has been, hey, you need to go in and start executing this pod. And then that node will instantiate it, and it's making updates to that object as well. It's adding status information. It's adding in all of these other things. So it's not so much that, it's not a database in the sense of, row values being stored, but it's critically important to the functionality of OpenShift, of Kubernetes, right? Every object has many different operations that are happening around it and with it and against it. So yeah, I think that was accurate. I'm looking to you to.
No, that's you're spot on.
Okay. So I want to, and usually these conversations when we talk about etcd turns into a performance conversation. Yeah. And I say that because performance is most frequently the issue that people have with etcd, right? And it ripples out into all different components, all different aspects of the cluster. So as I said, if I create that object, a pod, if it takes too long for that to be committed into the database, right, that can cause other issues, right? It takes longer to schedule. Once the scheduling happens, it takes longer to actually be instantiated. Once it's been instantiated, it takes longer for each one of those operations. And there's, hundreds or thousands of operations, depending on the size of your cluster, that could be going on at any point in time. So slow performance affects basically everything. And I want to start the performance conversation and kind of build into it by starting with, how does etcd actually work? And usually for me, this starts with the Raft protocol. And what does that actually mean? And I actually have a very convenient graphic here that I'll point in. I'll plug into chat here. Nice. So this is the secret lives of data.com. It's a pretty simplistic explanation. Chris, I see you smiling, right? This one is pretty well known about how to break down and understand the Raft protocol and how it works with data persistence, which is what etcd uses. I'm just going to click continue here to more or less show what it looks like. And actually, I think I want to jump ahead.
Yeah, a little bit.
I want protocol overview. So essentially, the distributed consensus is the important part. So one of the nodes will be elected as a leader. Come on, we'll get there. And then the others will be followers. So in this instance, we have the 3 nodes that will go through. They all start as followers. They will elect amongst themselves a leader based off of whatever criteria happens to be defined. And eventually we end up with that defined elected leader. So from a change perspective, so let's say this green dot here is the API server.
Mhm.
The API server communicates with the leader and says, set some sort of value. So that value goes to the leader. The leader then logs it, and then it sends that data to the followers. The followers then log that data and then reply back, hey, we've got it. And then it goes back and it says, okay, we have enough nodes, right? Enough of us have agreed that we have this data. Now let's commit the data, right? And at that point, the leader will return back to the requester, the API server in the case of Kubernetes, that, hey, your data has been saved. So the really important part here is you noticed that once the data was sent to etcd to the leader, it had to go across, it had to get written, it had to go across the network to the followers, who then had to write it, who then had to come back to the leader and say, hey, we got it, who then had to go back and commit it, who then had to come back and say, okay, I've actually stored the data. So you notice there's a bunch of different operations happening there, right? There's at least, 6 writes and 8 network traversals happening across the 3 nodes in order for that data to be committed. So this is why when we talk about, in just a moment, I'll start, we can start talking about the actual requirements or the actual values, right? So the latency, the network for storage and network, et cetera, that we suggest. This is why they seem super low, because there's a lot of that traffic that happens and they stack on top of each other. So one request is a bunch of different, one request to write data is a bunch of additional requests on the back end at the database level, or at the etcd level rather. All right, so I will pause here. Chris,
So
Anand,
some questions,
please.
How does etcd, I mean, we're going to talk about this in depth, but how does etcd work? What are the dependent services or objects for etcd? Which I think is an interesting question, because like etcd is the heart, but there is some dependencies out there, like storage.
Yeah, I'm, and Anand, I'll throw out what I think my answer is, and please add on, correct me if needed. So etcd itself doesn't have other dependencies in Kubernetes, and I'll put an asterisk on that. But it does have infrastructure requirements. So of course you need to have the storage available, right? You need to have the network available, that type of stuff. So the deployment inside of OpenShift really has a dependency on the cluster, the etcd cluster operator. So this is what I have here. I'll paste this into the chat. And I say that because the operator is what's actually configuring the nodes or the pods in the cluster. So let me switch over to my my terminal here. And if I do a oc get pod OpenShift etcd namespace, so we can see we have these 3 pods up here at the top, one on each one of the control plane nodes. And if I do a describe against that pod, oh yes, I know I have to supply the object type. So if I describe that pod and come up here to the, let's make this a little bigger so hopefully it doesn't wrap quite as badly. So if I find my, where is it? etcd pod right here, you can see that it has a lot of values, a lot of data that's being passed to it. So all of this configuration data comes from the operator. So the operator is the one that says, hey, this is where you can find your certificate. And importantly, once we get down here into the actual script, right, we can see down here it's saying, hey, this is where all of your peers are at. This is where you can find the other nodes inside of the cluster. So while it isn't the concept or the implementation of etcd itself doesn't require something else in Kubernetes, OpenShift does. And so this is why we have like the whole bootstrap thing. And when we instantiate a cluster, we stand up the bootstrap and it creates a single node cluster that then instantiates the control plane and hands off to that now 3-node cluster. And so that's how we work around the chicken and egg. So I'll be quiet now and let Anand.
Yes.
Yeah, can I share my screen for a second?
Absolutely.
Yes, please.
Yeah, so I think, Andrew, you were in the money with all those statements, right? So etcd, has no prereqs. It's a day one, operator like you mentioned. So it's installed, with the cluster, a key part of the control plane. One of the prerequisites, though, for having good etcd performance is, a good storage backend, right? And, as you know, OpenShift is supported on a wide variety of platforms, private clouds, public clouds, edge networks and whatnot. So one of the key things to get good performance from your etcd operator or from your etcd database is to make sure that the storage backend that's back in the cluster is performant enough. And here is where this utility called FIO comes in, right? And so one of the things that you might want to do before you install your OpenShift cluster, and you're worried that you might run into etcd performance degradation issues later on, is to run FIO, right? So if you run FIO, that will give you a status of whether your storage backend is good enough or not, right? And again, even if you're on a cloud platform, let's say AWS or Azure or GCP, you have access to wide variety of disks, right? You have access to SSDs, ultra HDDs, ultra SSDs. You have access to NVMe, so ephemeral storage. You have access to so many types of backend storage, and each of them offer a different type of performance. So one of the things you can do is run this FIO command. So I'm going to copy this, put it up here. And so when you run this command, it usually takes a few seconds. You want to watch for one metric, right? You want to watch for a metric called the F data sync. And you want to make sure that the 99th percentile of that metric is less than 10 milliseconds, right? So we let this guy, run for a few seconds. And we observe, in my case, my cluster is, I think, on a cloud platform. And we will see in this case if this installation is going to be good enough to support a good etcd performance. So that's the output. And this is the different percentile metrics for F data sync. And you can see the 99th percentile is 465 microseconds. So that's around 0.4 milliseconds. That's way less than 10. So we are in pretty good shape here.
You're in real good shape.
Yeah. Or actually, the F data sync is the second block.
Oh, sorry.
It's still really good at 5 milliseconds.
Mm-hmm.
That's right. Sorry. Yeah. That's right. Sorry. Yeah. So this is 5 milliseconds and way less than 10 milliseconds. So I think we're still good in this case. So one of the things.
Sorry to interrupt you. I think we should have you on more because you're literally doing what was my next step. So thank you.
You can read our minds, so this is good.
I don't want to interrupt you if you're going to lose that thought, but we do have a couple of questions, if that's okay.
Let's take the questions.
So we say that etcd goes across the network. Does it utilize its own configuration for contacting the other members of the etcd cluster? Or does it rely on things like Kubernetes services to find and discover those members?
Good question. I will need to find the answer to that. That's a great question.
So I think the answer is it uses, so this is one of those things that the operator does. The operator basically points it to the other cluster members automatically. So before the operator, so prior to, so in versions OpenShift 4.3 and earlier, we use the DNS SRV records. So if you happen to go back in the docs and look, during install, you'll see that we require all of these additional records for etcd, for SRV records pointing to etcd. So that's how we did that peer discovery. But the operator, I think, takes care of that. And I thought that was one of the things that we see over here.
Yeah, we have got rid of the DNS requirements, but I'm not sure whether that goes through services or ingress or what type of network protocol it uses to communicate with other etcd pods lying in.
Yes. So if you look at so that command that I did earlier, which was the OC describe pod on one of those etcd pods in the OpenShift etcd namespace, you'll see, for example, there's some environment variables like all etcd endpoints or node underscore control plane underscore identification. It's etcd name, etc URL host, right? Those are the values that it's using to find those other members. And importantly, I think this is why the operator specifically is why, like, we can only tolerate losing, one of the reasons we can only tolerate losing a single node or recovering a single node of etcd at a time, because the operator has to be there to reconfigure the surviving nodes to point to the new node, so that way they can all recover.
Yep.
Yeah. Let's see, there was another question up here. The revision pruner. So what is the purpose of the revision pruner? And I don't know that authoritatively. I think it's, I very much to your point, Waleed, I believe that it removes older versions. So essentially, if there's a configuration update, it is responsible for pruning, right, the old pods that happen to be left there. So I'm going to share my screen again real quick to help answer your question about running FIO on CoreOS there, Sam. And the reason I'm going to share it is because if we switch to the documentation here, so we have this recommended etcd practices. Let me paste this into the chat here.
Thank you.
If we scroll down in this documentation session, you can see that we have some podman commands that we can use to run. And it would be pretty easy to translate that into, right, running inside of a pod or running inside of OpenShift. So that being said, I actually did create, let me see if I have the link handy. A while ago, I created a very simple gist that shows how to run etcd inside of an OpenShift cluster. But I think it's important to understand that this just schedules it as a regular pod.
Right.
So let me scroll down here. Right. So it's not going to be running on a control plane node, which is really the important one, because etcd is actually running on a control plane node. And while most of the time it is going to be very similar performance, it is not always going to be the same. And in particular, what I mean by that is, for example, the operator and the installer are designed by and created by and tested by engineering to take into account a lot of different quirks. The biggest one, or arguably the most well-known one, is Azure. So with Azure, we deliberately tune, and I want to get to these in a few seconds, we deliberately tune some of the etcd settings, as well as we use things like, I think it requests a 1 terabyte drive for the control plane nodes to account for all of the IOPS and all the other things that it needs. So the etcd, or excuse me, the control plane nodes may be substantially different than a worker node. In addition to just the worker nodes, you know, they come from machine sets oftentimes. So it's close, but not always the same. Just keep that in mind. And Anand, I think you had something to add.
Yeah, sorry, I was replying to a few questions in chat. Yeah, so, a couple of things, again, going back to the FIO example, right? So from a product perspective, one of the things we want to do is we want to integrate FIO as a part of the install process, right? So that way you don't have to run it and then, run the install. If we find that most of our customers are actually, having a need to run this, we want to make it as a part of our, day one install. Maybe when you, generate the manifest, or when you generate install configs, or maybe when you say, cluster create, we want to make sure the FIO utility pops up, checks the status of your disks and gives you a report, right? Whether you're good enough, your backends are good enough or not. If it's not good enough, it's going to splash a warning. We don't want to block install at this point, but we want you to be at least aware that, your fsync is at this level of percentile. So you could expect a good or a bad, performance from etcd. So that's one of the things we're looking at, is to bake in FIO as a part of the OpenShift install. So you're aware, prior to time, what kind of performance you're going to be getting, right?
Nice.
That's, point number one. Point number two, let me actually again share my screen here. Point number two is the fact that, okay, so now you have determined that, your HCD is not going to give you good performance. What are the options you have, right? So one is obviously you can upgrade to better storage, like you can upgrade to NVMe, maybe you can upgrade to Ultra HDDs and whatnot. The second option you have is you can always mount vadlib etcd to a separate directory, right? And we're going to provide documentation. I believe it's already there for most of the cloud providers, AWS, Azure, and vSphere, and I think even bare metal, to show you how you can mount external volumes for your vadlib etcd to a separate high performance disk and attach that to your cluster, right? And I'm going to dig that out. So give me a few seconds as Andrew is walking through the presentation. I will actually provide documentation on how to mount vadlib etcd to a separate secondary disk. And one of the things we're looking at doing from product side is how you can bake this in again as a part of maybe day one or as a day one install, right? So as you're installing through day one, if you want to use an external secondary disk for etcd, we want to provide you an option of doing that as a part of your day one install.
Yeah, I know that's something that has been asked about somewhat frequently since OpenShift 4 was released, and OpenShift 4 with CoreOS has been a much more rigid configuration, and a lot of people with OpenShift 3 would dedicate a disk to etcd. So
right,
I know that is something that is very much being looked forward to.
Mm-hmm.
So I'm going to share my screen again as well. And the reason why I wanted to do that is because I want to share this KCS. So this KCS kind of summarizes all of the things that we've been talking about thus far and kind of breaks it down into different component pieces. So for example, this paragraph here is arguably one of the most important, or this section here. So applying a request should normally take fewer than 50 milliseconds, where a request refers to the amount of time that it takes for the etcd cluster to commit or return a piece of data. And that 50 milliseconds is going to be the aggregate of all of those storage and network latency operations. And that is why we make kind of stringent, requirements around the performance. So we can see here, slow disk, P99 duration should be less than 10 milliseconds. So database size related issues. So we'll talk in a little bit about what defragging and compaction is and how that can impact the performance as well. Overall latency comes from network latency as well as storage latency, right? So here you can see that we don't provide a specific network latency requirement. Instead, it's wrapped up in this 50 millisecond number. So if your storage is slower, then you maybe need faster network to be able to reach that 50 milliseconds, right? That type of stuff. So it's very much there's a lot of a balancing act.
Yeah, there's a lot of knobs, is what I was about to say, that you can dial in and dial out to kind of get to where you need to be on a large infrastructure kind of setup.
Yeah, and the other one that I wanted to share is this KCS. So I created that super simple gist. So this one is very simple. Here they recommend doing an OC debug into the master node to do that same podman command.
Nice.
So I'll post that KCS in there as well.
I'm gonna save that one because that's a handy one.
Yeah. And let's see, what other links do I have out here? Cluster storage operator. Oh, we already talked about that. So let me check my notes, and Anand, please interrupt me at any time if you're whenever you're ready. So one of the questions that we get a lot is basically what happens if my storage performance is right on the cusp, right? What if it's right at that 10 millisecond range? What if it's, when I measure operations? Oh, one thing I should talk about here is etcd control. So if we go to, where am I looking here? So if we go to the official etcd documents, we have a command, which is etcd control, right? This is how we interact with it. And you can connect to, you can utilize from a control plane node, you can use etcd or etcd control to interact with it. And specifically, if we come down here to, if we come down here to the operations guide and we look for performance, there's going to be a set of commands that we can run against the cluster. And the one that I'm looking for that I'm not seeing at the moment. So there's the benchmark CLI tool. There's also etcd control, etcd cuddle, check perf -- load equals, and then we have small, medium, large, extra large. So effectively what that's doing is the etcd control is running a workload, right? It's doing a bunch of queries and a bunch of other stuff against the cluster and then returns back some data from that, some values. And that was where did I just do? What did I do with that gist? I thought that, or I think that one of the things that I was showcasing in there is the output of some of those etcd control values. So essentially, this is a good way to determine or identify what that, and let me go back over here to our KCS, right? What that request latency or what that overall request time happens to be, and gauge whether or not your cluster is capable of meeting those requirements. So let me catch up on chat real quick here. Fastest disk you've got to etcd, yes. Chris, I see that's you.
Yeah.
If you want to check simulate disk events, thank you, Waleed, for the link. I'll have to check that one out. Anand, I see you're answering the question about how the pods communicate with others. They use the host network.
Yep. Thank you for saying that, because I was about to type it when you hit enter.
Christian, yeah, I'm an equal opportunity offender. I try and switch back and forth between all of the different pronunciations of all of the different control, cuddle, and CTLs, whether it's for Kubernetes, OpenShift, etcd, Trident. Trident's the NetApp CSI provisioner. Yeah. Okay, so I think I'm caught up on chat. Please, just a reminder, anybody feel free to submit questions at any time.
Yeah, and Andrew, as you're looking at the questions, there are two links I would like to share with the group here. One, as I mentioned, is how you can use the secondary storage for etcd. So this is a KCS article on how you can mount secondary storage. I guess this is not just for etcd, right? So I mean, any file system in OpenShift, could be wireless containers. So this is that generic article, and specifically for etcd, and specifically for cloud providers like bare metal and vSphere, there is actually detailed instruction on how you can mount warlib containers, warlib etcd, and for that matter, just /war on a separate file system. And let me paste a link to that as well. And the key thing I want to make at this point is, as you can see, these are day two tasks, right? After the cluster has been created, if you want to mount /warlib etcd to a separate secondary disk that is highly performant, here are the steps to do it as a part of day two. But we're looking at taking some of these steps and making it as a part of the day one operation. So you can do it right as the cluster is being installed, and you don't have to worry about doing it day two. So that's something we're looking at from a product side.
Nice.
Okay, so in the interest of time, I think I'm going to move ahead a little bit. So we've beaten the performance side of the house. We've beaten that into shape, I think. If anybody has any questions, please let me know. We have a bunch more resources that I'm going to include in the show summary blog post. So those go out Friday mornings on openshift.com/blog. So I'll have just a huge amount of links. Literally, Chris and I were talking like 2.5 pages of notes leading into this session. I'll include all of the links and stuff there. So troubleshooting. How do we identify, how do we know that there are issues happening with our cluster? So let's go to my cluster over here. And the first way, as always, will be, you'll see logs about it. Right?
Oh, yeah.
You'll start seeing some
events.
start seeing some events. What's going on here, cluster?
Oh, you got to log back in.
Apparently it logged me out.
Oh, there you go.
My token expired. So you'll start seeing some events, you'll start seeing some alerts happening inside of here, right? There'll be all kinds of things that are basically saying something's really, really wrong. And usually it'll also ripple out into other things.
Your
Right? There are
services
other
will start-
operators, there are other pods that'll all start complaining as well.
Mhm.
So usually when it becomes a problem, it's very obvious. So now how do I actually determine how bad the problem is? And fortunately, in the performance dashboards here, we have one that's dedicated to etcd.
Thank you.
So yeah, and this one has been here, I think, since day one.
Yeah, I don't recall an OpenShift that didn't have this.
Yeah, and we sometimes add and remove charts and stuff like that are here, and there's also a tremendous amount of additional information available in Prometheus that isn't in the dashboard. So if I jump back over here to this recommended host practices documentation page, you'll see that it suggests some additional values that you can check for, that you can monitor inside of or via Prometheus. So the dashboard is just meant to be a quick and easy way. So for me personally, the one that I pay most attention to, or the ones that I pay most attention to, RPC rate is generally how busy it is overall, right? So you would expect this to go up as the cluster increases in busyness. And I specifically use the term busyness here and not scale. So because I can have 3 nodes that are absolute monster nodes that have 500 pods deployed to them, and those pods are super busy, and they are generating a lot of activity. Or I can have a cluster of 100 nodes that have 1 pod each that are not doing a whole lot, and therefore it's when we talk about scale for etcd and how it affects the scale of OpenShift, it is more about the number of objects in the database in etcd rather than the number of or the size of nodes, right? Type of thing. So arguably the most important single metric is this disk sync duration. Let me turn that off so we can make it a little bigger. So this disk sync duration is literally the latency for writing values to disk for each one of the nodes. So pay special attention to that one. This is a good indicator if you're having issues with that storage latency problem. If we look down here in the various peer traffics and client traffics, this can sometimes be an indicator of network issues, right? If you start seeing 1 node or 2 nodes that are having a surge in traffic, or 1 node that's way below the others, this doesn't count. So you can kind of always expect 1 node to have more peer traffic because that's going to be the leader. The leader is going to be having additional traffic. But yeah, if you see one that's really an outlier, right, something like that, then that can be an indication. And then of course the total leader elections per day, this one will be obvious. So remember when I showed the Raft image, the first thing it did was elect a leader. And then that leader is the one that handles all of the read-write operations for the API server. So if it's having trouble, or if the other nodes are having trouble with it, they can basically say, I don't trust the leader, I need to elect a new leader. When that happens, it basically pauses everything. It doesn't do any reads, it doesn't do any writes, it just stuns the whole cluster. And that will very much ripple out across the rest of OpenShift.
Very quickly.
And that means the API server stops responding, right? All kinds of other stuff. So if you have, something as simple as like doing an OC logs -f, oftentimes it'll cause the API servers to drop those connections and stuff like that. So you'll start to see those leader elections happening. That is a strong indicator that there is something bad happening inside of there. And then of course, okay, we've identified something, right? We think that it's X or Y or Z. We see it in the events. You can also, of course, check the pod logs. I showed how to do that a moment ago on the CLI, just OC logs against the pods that are in the OpenShift-etcd namespace. Okay. I said before that we were going to talk about some maintenance tasks. Anand, I think you probably have a better method of describing this than I do, and I'll catch up on chat while you're running through it. So can you tell us what compaction and defragmentation are within etcd? And if not, I do have an answer, and that I may just need to rely on you to say, yes, Andrew, you're right, or no, Andrew, you're wrong because.
Now, why don't you go ahead with your answer? I'll correct you.
Okay. So my 2 cent or my layman's version is that compaction removes key history. So it's etcd is versioned, right? As I add new data, it basically creates new versions of those keys. So when I compact the database, and we can see here in the metrics, we have this DB size. When I compact the database, it just goes in and it removes all of those old versions. But when it does that, it leaves holes in that capacity, in that space utilized. And this is not necessarily a bad thing, particularly if we're talking flash media. It's not like we have to wait for seek time or something like that. But at the upper end, when we're talking about a very busy cluster of a very scaled up cluster with lots of pods, lots of other things stored in etcd, this database can be pretty substantial. So after doing a compaction, it's usually recommended to do a defrag, which takes all of that data and brings it down, just like those of us who've been administering systems for a while, right? Just like we did with spinning media, right? It brings all of that data so it's contiguous on the disk. And effectively at that point, it returns to the system all of that now unused capacity. So it reduces the size of the database. So this is why it can impact performance, right? Lots of other things. So a couple of important things here. If you look at the etcd documentation, what happened to the documentation? Here we go. It'll make a lot of, frequently asked, and I lost where I had it inside of here. Anyways, inside of the FAQ, it'll make recommendations. And keep in mind, this is the upstream, the official etcd documentation, not specific to OpenShift. Here, recover from low space quota, compact, defragment, and then do away with the alarm, right? Stuff like that. It'll make these recommendations. It is technically possible to do this manually inside of OpenShift. However, we don't recommend doing that. And the reason is because the system does it for you. So compaction, and Anand, please correct me if I'm wrong, I believe compaction happens every 5 minutes automatically, and defragmentation happens whenever the nodes are rebooted. The rationale being compaction, it's happening frequently. It's a relatively low IO workload when it happens. Defrag, on the other hand, is a relatively high IO workload. So if we were to do that against a running node in the cluster, it would basically, the expectation is it would impact disk performance, which would ripple out into other aspects of etcd performance.
Right.
So we automatically do it when the node is rebooted before it has rejoined the etcd cluster, so that way it's not impacting other things inside of there. Go on, Zoom banner, get out of my way.
Yeah, that is right, Andrew. Just to summarize, compaction is deleting key history, and defrag is reclaiming the empty space and returning it to the OS.
Mm-hmm.
Compaction, to confirm, occurs every 5 minutes by default, and defrag needs to be initiated by the admin, right? So the etcd commands, or the etcd control commands, Andrew, that you're showing, has a flag for defrag, right? So you could just say etcd defrag, something that can be initiated by the cluster admin. It should take a few minutes, and that should complete the defrag. The compaction happens every 5 minutes.
Yeah. So generally speaking, unless something else has gone adverse, has gone sideways, we wouldn't expect for those to need to be done manually, even in a very busy cluster. Right. Assuming, and I know this is a big assumption, as I have learned the hard way, assuming you are rebooting the nodes regularly.
Which means you need to be updating your nodes regularly.
Yeah. So effectively, we release Z streams every 2 weeks-ish. So, we can kind of reasonably expect most nodes to be rebooted at least once every 2 weeks. And of course, if you're configuring or changing other configuration with MCO, that would result in a node reboot. That may be more frequent. So just be aware of that. Yep. Well, every 1 to 3 weeks is usually kind of the average. I would think anecdotally for between node reboots. So the last thing that I wanted to talk about, just very quickly is, and then Anand, I want to hand over to you with at least 5 minutes to go to talk about roadmap, is backups. A lot of people talk about backups, and I think it's really important that we understand that for etcd, backups are not necessarily great for disaster recovery. And you may be thinking, that's literally why we create backups, Andrew, right? Why are you telling me that I can't use that for disaster recovery? So the backups are literally a snapshot of the database, of the etcd data space. And remember, all of those objects represent the literal configuration of Kubernetes, of OpenShift. So if I were to suffer a catastrophic event at my site, right, with my database, I can, at that same site with that same OpenShift, right, it's the nodes are still up and running, just something happened to etcd. I can use that backup to restore it, and it'll come back relatively quickly, right? So the support folks are super good at figuring that out and getting things up and running again. But let's say that it's a disaster recovery scenario, right? Something happened at the primary site and it's not coming back, not for a good long while. I need to recover on the DR site. That DR site is almost guaranteed to be different in some way. And if you recover that backup etc database, it doesn't know that. It's going to come back up and it's going to think that everything is exactly the same as it was. So my personal opinion, and I think, I can't see Christian, but I'm pretty sure he's going to be nodding his approval, is to take kind of a GitOps approach to DR, right? Of
Right.
don't literally move everything, instead reinstantiate it on the destination side. I know that's probably a little bit controversial. Please feel free to beat me up in the comments or publicly on social media, etc. I'm happy to defend my position on that. But sometimes we have to think a little bit differently about how things are done in Kubernetes. So with that, Anand, I want to hand over to you. We've got 7 minutes left to, one, correct me, tell me how I'm wrong, and two, talk about the roadmap.
Sure. I just want to complete your conversation on backup, Andrew, if you don't mind, and then I'll wrap with the roadmap.
Please.
So on backup, I just want to show a couple of ways you can back up the etcd cluster. So here is some good documentation around it. This is for 4.7. I'm going to paste this link here. But essentially, if you do OC, let's go back here. OC get nodes. So now it's a OC debug node. Let's pick one of the masters. Let's pick the first master. And then you would navigate to the host directory. And then you can run this command, right? This is user local bin cluster backup.sh, and then specify where you want the backup to go. In this case, home core assets backup. Once you do that, it again takes a few minutes. It backs up the etcd database, and it also backs up all the etcd pod resources. So if, let's say, now we go to this directory, home core assets backup, you will see two resources, or at least two resources. These are two backups, so you see four, but the point is you should see two resources. One is the backup of the database itself, and then the backup of the static pod resources, which also has the encryption key. So make sure that if you're backing these two things up, you don't leave them at the same place. It's kind of like, locking your house and leaving the key, right outside the doorstep.
Yeah, just right there in the lock.
So make sure that, their two separate files are, stored in separate places. But to restore it, you will need this file, which contains the static pod resources because it contains the encryption key. So that's, basic, example of a backup. Let me see if I missed anything. Yeah, the other thing to note is we back up only the values and not the keys. So if you have resource types, namespaces, and other object names, they will not be encrypted. So make sure you don't put, confidential information in namespaces and, other resource types, right? So that is around backing up etcd. There is again a procedure for restoring from the backup. I'm not going to go through the sequence here, but I will paste the instructions, and you can.
I just did it. Well, you did it too.
Yeah, you can easily restore from the backup, and let's see what else. Yeah, last but not the least, encrypting etcd, right? As you know, a lot of the important state information of the cluster is stored in etcd. And if my browser cooperates here, I'll show you how you can actually encrypt etcd. let me actually, so one of the things you can do is you can say, exit out of my master node and say OC edit API server.
You got a dollar sign beforehand.
Yeah, OC edit. Copy paste magic. Yeah, so if you see OC edit API server, this contains the config information of the API server. And you can see that the encryption has been turned to AES CBC, which means, all the etcd resources, which includes the OpenShift API server, the Cube API server, and the OAuth API server, all of them are encrypted. If you want to turn this to off, you'll just change the type to identity. So you'll just change the encryption type to identity. And if you want to turn it back on, you'll just specify the encryption type. Once you specify the encryption type, you save this file out, and it should take a few minutes for the API server to recycle and apply encryption. Now, if you want to check if all the resources are encrypted, starting with the OpenShift API server, you'll punch in this command. You can see encryption is complete. All resources are encrypted, including the routes. Next, let's check the Cube API server. Again, you can see that secrets config maps are encrypted as a part of the Cube API server. And last but not the least, the authentication operator or the OAuth API server. As you can again see, encryption is completed for OAuth access tokens, for OAuth authorization tokens. So pretty much all across the board, all resources have been encrypted. And again, like I said, if you wanted to go back and unencrypt etcd, you just go back and flip the encryption type back to identity, and again wait for a few minutes, and the encryption should be turned off. So again, it's pretty straightforward. I'm gonna paste this link. Let's see, did I miss anything else in encryption? That's pretty much it. So we learned how to do a backup, to do a restore, to encrypt and de-encrypt etcd and all the resources that are encrypted as a part of the process. And I want to wrap. I think we have 2 minutes. I want to wrap with the roadmap.
Yeah.
What's coming up next. So etcd has been bumped to 3.4.9 is what the slide says, but I believe the latest update is 3.4.14. I believe that's what is the latest version. We want to improve disaster recovery and backup, right? So you saw me doing manual backups, you saw me doing manual restores, but where we want to get to in the future is to have a more automated way of doing backups and restores, right? So what we want to do is provide a config file, like a YAML file, where you can specify how often you want to take these backups, where you want to store these backups, how you want to name these backups. For instance, if you want to take periodic backups every 24 hours, and then send those backups to an S3 bucket in AWS, we want to provide a config file where you can specify the automation around that, right? So we're doing a lot of work around improving the backup and disaster recovery scenario, like taking snapshots, restoring from snapshots, storing those snapshots, specifying how recurring those snapshots should be backed up, and things like that. So that's one of the major things we're working on. The other thing we're working on, like I said, is moving secondary disks for etcd as a part of day one install, so you don't have to worry about setting it up as a day two operation. And with that, you can get access to faster disks as you're setting up the cluster. The other key thing I want to point out is we are looking at scaling up and scaling down the etcd operator. So as you know, the default install of OpenShift comes with 3 masters. But let's say you want to scale down to a single node OpenShift, maybe for code ready containers, or maybe for edge deployments. For whatever reason you want a single node deployment of OpenShift, you want to make sure that etcd supports those single node deployments. So those are some of the things we're looking at in the near future that we are actively working on, and also always improving performance, always trying to gather more metrics from Prometheus, and always trying to make sure that the cluster is reliable. Those things will never go away.
All right. Well,
Awesome.
Thank you, Anand. And I know we are right at time. I know we are
Yes.
backed up against the OpenShift Commons session that is coming up. So thank you very much, Anand. We greatly appreciate you coming on and sharing with us today. Thank you very much to our audience. Greatly appreciate you sticking with us, asking all of the phenomenal questions.
Yes.
If you have additional questions, please don't hesitate to reach out to either Chris or I. So I am on Twitter at Practical Andrew, just like my username here in Twitch. Or Chris is at Chris Short on Twitter. You can also and you can also reach out to me via email, andrew.sullivan@redhat.com. We're happy to answer any and all questions that you have, whether they're about etcd or not. Don't hesitate to reach out. And thank you very much.
Thank you all.
Yeah.
See you in a few seconds.